Hey guys, today we're going to start looking at the true giants of this field, the so-called laws of thermodynamics. Just for the hell of it, let's go ahead and start with the first law. That means we're only going to be looking at closed systems today. Alright, let's have some fun. Like I said, today we're going to be checking out the first law of thermodynamics for closed systems. If you don't know what a closed system is, there's no need to start crying about it yet. We've got a video right here on thermodynamic systems, so just have a look at it first and then we can keep going. Okay, so here we go with the first law of thermodynamics. So what's this law say? The first law is the one that describes the conservation of energy in systems. The special thing about the first law, though, is that it allows for the transformation of energy. And to fulfill the condition of conservation of energy means that energy just can't randomly appear out of nowhere, and it can't be destroyed all of a sudden either. Yep, it's gotta be conserved. It's almost like you'd be able to guess that from the name. So far so good, but definitions won't get you very far in the exam, unfortunately. We need a mathematical formula for all this. And here it comes. Hold tight. That beast is the general formula expressing the first law of thermodynamics for any open system. But since all we're going to be looking at today are the closed systems, and we're not interested in proportions of potential and kinetic energy, and we're not going to be worrying about stuff like net loss for now, we can reduce this equation to a few simple terms. That's much better. This is something we can work with. Let's look at each of these terms one by one. The only thing on the left side is delta U. The U here stands for internal energy. Basically, this term represents all the energy currently contained within the system. So you can pull all the energy out of a system like this and use it to, say, run your toaster. The little triangle is just a delta, and it basically means change. This means that what's represented on the left side of the equation is the change in internal energy in a system. This change is always equal to the right side of the equation. And what's there on the right? Over here we've got a Q and a W. In this case, the Q represents heat, and the W just stands for the work that's done by or on the system. So this means that the first law of thermodynamics say that in a closed system, the change in internal energy is always equal to the sum of the heat and the work supplied to the system or produced by it. That's pretty much the gist of the first law, so make sure you remember it. Let's have a look at a concrete example to see how all this works. Like any good example, we're going to show you a completely nonsensical contraption. What we have here is a gas that's being compressed by a piston and heated by a wire at the same time. The system is closed so that the gas can't leak out and no more gas can get in. The piston performs 400 joules of work, and the heating wire emits 350 joules of energy. So let's set up the first law of thermodynamics for this system. It's super important that we determine the direction of the processes here. With regard to our system, we need to decide whether energy is being added to the system or produced by it. In this case, the work done by the piston is added to our system, which means that the work gets a positive value. And since our gas is being heated, heat from the wire also flows into our system. This means that the heat is also positive. Our super equation gives us the following result. This result tells us that the internal energy of the gas has increased to 750 joules. Generally speaking, this means an increase in the temperature of the gas. That's how simple it can be. Now, if we had a cooling plate instead of the heating wire, the value for the heat would have been negative. Makes sense after all. Cooling takes heat out of our system. And that's pretty much the essence of the first law of thermodynamics. Basically, this is how it always works. You try to find out how the individual terms fit together and what kind of effect they have on the system. Okay, so let's sum all this up. The first law of thermodynamics describes the principle of conservation of energy in thermodynamic systems. Energy can be transformed in this case. For example, heat can be converted into work or the other way around. And the simplified mathematical expression of the first law of thermodynamics is delta U equals Q plus W. Because of this, we now know that any change in the internal energy of a closed system always comes about due to heat and work added to or produced by the system. If you thought this one was too easy, you can jump right into the next video on the laws of thermodynamics. Go ahead and dig in. We'll see you there.